when I thought about what I wanted to do in the defense space, it was, I want to go have a really, really big impact on the security of our country. Like there are big problems. How do we go have a really big impact? And hearing the work you've done with Palantir and Anduril and other defense tech companies, and actually the story about giving Palantir to the Army for free because soldiers were losing their lives in Iraq, like that's the why, right?
Yeah.
That's the why we're doing this. And then building out the what and the how with a partner that has been there before, took an idea and let us go execute on it very, very quickly. In what would have taken 8 or 9 months to figure out the blocking and tackling, we basically stood the company up overnight.
I love how fast you've been moving in general. This is one of the fastest companies I've seen from getting going to where you are. I think you're planning on ramping it up to, I don't know if we could say, but a large number of ships per month in the next year. Is there anything you can
That's
say?
right.
What's the pace you're trying to go here?
No, I mean, we've focused on manufacturing from the very beginning. We talked about all the different things we did. The thing that delivers the overwhelming force that the military needs is ultimately scale. So we started with that thesis point in mind, and we said, look, we can go and design a cool boat, and we can write the best software in the world. And if it's not made to be put together and manufactured at scale, then it really doesn't matter. And so we've been focusing on that from the very beginning. One of our very early hires is our head of manufacturing, comes out of SpaceX. He's always talking about how do you build the machine that builds the machine.
There's a lot to learn from what Elon's done, bringing back skilled manufacturing to the U.S. So
100%.
I'm not allowed to steal any of these people myself.
But to answer your question, the military needs hundreds and then thousands of these types of platforms. That's where they're headed, and that's where the demand is.
Hopefully we can get to thousands a year. That's, let's talk about the state of the U.S. Navy actually a little bit. So the U.S. Obviously had the most powerful Navy in the world at some point around the time of World War II.
Yep.
And after, I remember stories where every time they destroy one of our ships, we'd have 2 or 3 more out there pretty soon. I remember, is it true the Germans, I think, had better ships back then, but we had a lot more of them? Is that true?
Yeah. Tanks. When you look at the military platforms back then, what our defense industrial base was able to do is absolutely incredible.
The forge that America built with its private sector helping was the best in the world.
100%. And when you talk about the Navy specifically, I mean, you go back to 1943, we built over 18,000 naval vessels in 1 year. We built over 125 aircraft carriers that year.
Wow.
Today, the U.S. Navy has 11 aircraft carriers.
That's embarrassing.
They cost $10 billion and they take 10 years to make.
It sounds a little bit more like a bad version of the Germans back then, where we have the very, very best stuff, but we don't have nearly enough of it.
Our defense industrial base has changed over the last 40 or 50 years. We're not able to produce anywhere near what we used to be able to. And that's why we have to rethink the problem.
I'd imagine our 11 aircraft carriers right today could probably win a war against 125 aircraft carriers from 1943, I assume, right?
Well, quantity is a quality all of its own. Yeah. And so when you have a defense industrial base that essentially keeps replenishing the platforms, and that's what we're talking about doing with our platforms now, right? Mm-hmm. If you have attritable platforms that are meant to go and deter an enemy and you send them out into combat and they don't come back, you better be able to backfill them. Otherwise, you're essentially out of ammo. And if you're out of ammo, you lose, right?
People don't realize how much war is an engineering game. When you talk about engineering, right? Engineering is dealing with scarcity, right? So if you want to design a bridge, anyone could build a bridge with infinite money. The question is, how do you build it really, really safe to last a long time without, by using 100th less metal, right? It's the same thing with everything else we're doing. And so one thing, of course, our most important adversary, unfortunately, right now is China. China is the biggest adversary. And I think most Americans would be pretty shocked to learn how much more shipbuilding capacity China has. What's the situation right now?
Oh, well, look, you want to start with the overall premise of, in modern history, global power has been determined by naval power, and naval power has been determined by who has the most ships. So that's a pretty easy equation that even I can understand, right? Now, we talked about a little bit about what has happened to the U.S. defense industrial base, specifically around shipbuilding. So we built 18,000 naval ships. Do you know how many we built last year?
I guess it's in the kind of tens.
8.
Wow, that's even less.
And we retired 12.
So that's negative.
We're -4 in a peacetime environment. Now you overlay that with what the Chinese have done over the last 30 years.
I mean, they're building hundreds or thousands a year.
They have 250 times our shipbuilding capacity, and they have 50% of the world's shipbuilding capacity. That means if you got the entire world teamed up against China, you're only at parity.
Wow.
That's scary, and that's a lot of power to be concentrated in any one country. And that's why we're building what we're building, and that's why we're building it so fast.
So basically, we're going to ramp up and we're going to help build hundreds and then thousands of ships per year. These are smaller ships. Why does that make more sense?
Well, when you talk about changing the dynamics of warfare, and you see this happening in all domains, you're seeing examples of it in the Ukraine. It's a big shift from large, expensive, exquisite platforms that are manned to attritable autonomous platforms that can be produced economically at scale. Look, our country isn't what it was back in the 1940s, right? Even if we could hypothetically build that many ships, do we have the sailors to man them? And do we want to man them with people when we can make them fully autonomous, right? You're seeing in the Ukraine how small unmanned surface vessels can essentially immobilize the Russian fleet in the Black Sea.
The Russian big ships had to all leave the Black Sea, right?
They can't move.
Yeah.
So when you talk about doing that at scale against a much larger fleet, potentially in the Indo-Pacific, or just maintaining naval superiority, it's being able to roll these things off an assembly line so you can constantly fill the supply and constantly backfill. It's attritable autonomy that can overwhelm a much larger force.
This is basically a new era of asymmetric warfare. We have all this new electronic warfare. We've had obviously Dino on from Saronic. He's hopefully building thousands of these small autonomous weaponized vessels in the water. You have swarms of these things. What does it look like for ground campaigns in let's say 10 years from now, even if we've done this correctly? Like, how's a ground campaign different than it is today for the Army?
Yeah, so we're building autonomy, which will allow you to just direct vehicles to go from like one location to another. That means that you have operators which are removed from those vehicles. So hopefully that makes the operator safer. And then with autonomy and effective command and control, we're building technology which will allow an operator to select and task multiple vehicles on the battlefield. So the basic idea is that a single operator can control multiple vehicles and be a force multiplier on the battlefield.
So the way I see it is, even in the last 20 years, the special forces have become more important. You have these very small elite groups that are commanding a lot of information. They're calling in airstrikes. They're able to do a lot of things with a few number of people. It seems to me like the whole Army is maybe going to go that way, where even a small number of people in a platoon or whatever you call it that are forward deployed, maybe each person in that platoon has multiple different robots around them, kind of helping them that they're controlling. And so one group of 10 people might even have 50 or 100 different ground robots that each have different abilities to fight with them, protect them, breach things. Is that where we're going? Is like you get a lot more force per person in a battle?
So yeah, that's a powerful vision for the future, and we are trying to enable technology like that, where a single operator can control multiple vehicles and therefore project more force on the battlefield.
One of the things we were talking about earlier that really stuck with me was these Army engineers. Teach our listeners, like, what does an Army engineer do in these different scenarios? It sounds like a really risky job. You got to be right at the front, dealing with breaching, dealing with complicated things. Like, what's their job?
So combat engineers have a pretty wide variety of jobs, and we've been discussing operations like breaching operations with them, which is extremely dangerous.
What's breaching?
So breaching is basically forming a path through enemy defenses. So it's an extremely complex operation and also something which is very, very dangerous. So we're working with the combat engineers to provide them with tools, basically autonomous vehicles, which allow them to execute portions of that operation without putting a human in harm's way. So that's the basic idea.
Let's talk about how breaching would work. Normally, so you have a place, there might be all sorts of mines, there's just bad guys, there's walls, whatever. So you could go forward and you I think there's these giant vehicles that like throw these explosive ropes forward. What is this called?
So those are called MICLICs.
So you throw these MICLICs, and how big an area do MICLICs clear potentially during a big breaching operation?
So they'll clear up to about 100 meters in front of the vehicle.
This is cool. So this is like, we can show maybe on the screen what this looks like, but you're throwing this giant thing forward. It's 100 meters long. It's maybe 10 meters wide, 20 meters wide.
Something like that, yeah.
And you're blowing a bunch of crap up. So there's all these mines. They're hopefully exploding it. You're creating a path. And then before you can take soldiers on that path, you have to make sure a path is cleared. So then the Army engineer has to drive over that path, right?
Yeah, that's right. So it's an operation like that. I'll leave the details to the expert, but basically, what we're trying to do is provide them with autonomous vehicles to make operations like this a little bit safer.
Well, I just imagine being the combat engineer whose job is now to drive something over that. Like,
Yeah.
I'd much rather have you on my team first. So we should hopefully these guys are, and these guys are trying to work with you, I imagine.
That's right. And I think just in general, one of the ways to think about this more broadly is that really what we're trying to do is take the most dangerous jobs in the military, and especially when you're in vehicles, and maybe replace those roles with autonomous vehicles so that you can take the human out of harm's way.
So going back to the founding of the company, like, what is Overland AI? Give us like, what is this company?
Sure. So, we got started with work I was doing in my academic lab at the University of Washington. Like I said earlier, we've been doing some work with Army Research Lab and DARPA on developing new capabilities for ground autonomy, basically trying to develop an autonomy stack that enables a vehicle to move through the sort of complex and contested terrain that you would find in military applications. And through work with these organizations, with Army Research Lab and DARPA, we developed capabilities that we thought were game changing. So basically the idea, basically capability where we can move a vehicle at high speeds from one point to another in a wide variety of terrain and do that reliably. And so once we had a capability like that, we were looking at the military and trying to figure out, okay, like how do we actually get this into the hands of the warfighter? And so we decided to form a company to basically take those capabilities, turn it into a product, and iterate with warfighters and get it back into their hands so that they have the technology and can actually use it.
And your first products, you've been equipping others. You actually made a huge amount of revenue last year where others have existing vehicles and you're equipping these vehicles to be autonomous, right?
That's correct. So in our first several projects with the U.S. military, we have taken, they have provided vehicles for us, and we've put our autonomy stack on those vehicles. So essentially taken hardware that someone else has created and turned it into an autonomous asset that you can move around, remotely by something called like waypoint navigation, where you will drop a waypoint and the vehicle will autonomously go to that location.
We came about founding, and you were part of that founding team, Joe, founding Epris. We said we need a defense company, electronic warfare company, that can build systems that will attack that particular type of threat, asymmetrical or regular. And we came up with high-powered microwave. And we highly leveraged basically these ideas we had in Next Generation Jammer and other places where we said, why wouldn't this work in high-powered microwave? And that question just wasn't even asked in the DoD. They didn't ask it. They had a blind spot to actually this approach. And Bo said, no, we want to do it. We want to try it. And what he did was he created basically a similar structure to Next Generation Jammer that had a software-defined back end of the system, so you could program the computer to do whatever you needed it to do. And the front end was a phased array powered by the substance called gallium nitride. And so those two things basically coupled together created sort of the most impressive electronic warfare system that the military has ever fielded. And oh, by the way, Next Generation Jammer just went on its first deployment with the USS Lincoln. So now it's being shipped overseas. So by taking kind of lessons learned there, we've applied it to a phased array, which means what a phased array is an antenna that can electronically scan a beam. So you can push high amounts of energy out towards a target, surround that target with the electromagnetic fields that cause disruption and disablement of their circuits, and then scan that beam very rapidly in a blink of an eye, in microseconds, across large portions of the sky. So in effect, what you have done is you've created an electronic warfare shield or wall.
You can kind of visualize it like a Star Trek shield if you want to, where you have a base and you have this like shield, and that Star Trek shield is basically turning off any sort of electronics that would pass through it.
Absolutely right. Absolutely right. And it can self-protect a air base. It could self-protect a tank. It could self-protect a helicopter. And I could keep going. And we have activity in a wide spectrum of different sorts of applications that range from a very sort of close range self-protect, like the Abrams tanks, for example, ranging all the way up into the protect a whole entire airfield.
So you could protect planes, tanks, airfields, groups. I mean, I guess you're seeing the Russian tanks are being taken out by these really cheap drones that are flying at them. I imagine if we had tanks too, they'd try to use drones against us. Like, how far away do you have to take out a drone so it can't kill a tank? Wouldn't it just keep flying and explode you anyway? How does that work?
Well, no, the interesting thing about what's happening there, and I think the Ukrainians or whatnot did lose a couple Abrams as well this way. What happens is a first-person viewer drone with what they call a contact charge needs to drive that first-person viewed drone all the way into impact.
Yep.
Because how the contact charge works is it hits the armor and then a little spike shoots through the armor and then blasts it out from the inside, creating a vulnerability. And then it's attacked by a subsequent charge, blows up the tank.
Got it.
If you knock down that drone 5 feet from the tank, no effect. Doesn't do any damage. So 5 feet, 10 feet. So what we've done is we've engineered, and because we've got a lot of the elements at Epirus of product companies, we built the Epirus product, Leonidas, with the idea to be hyper scalable, that each one of the little elements inside can be sized and shaped to different missions. So on the case of the tank, we just have a few of those elements basically on either side of the tank that creates a close in, let's call it force field.
So basically you could have some force fields that it's probably classified, but they might go like miles, and you could have other force fields that might just go yards, basically, depending on how much.
Exactly right.
And there's been talk a lot of, obviously not just drones, but drone swarms, dozens, hundreds, thousands of AI-enabled, battle networked, drones, attritable units acting in coordination. We're trying to build versions of these, obviously, in different companies. What makes HPM a viable solution against the swarms? Like, you can turn off all of them at once?
Well, that's the thing. It's a wider area effect technology. So where you have lasers, you think of a laser has a very, very tiny little beam that needs to hit one target at a time and burn through that target and then disrupt it. A microwave system, especially at the frequencies we're using, can be very broad and spread. So we can spread all of that microwave into the atmosphere, and everything in that section of the atmosphere would be affected by that electromagnetic radiation. So it lends itself, just by the sheer nature of what we've brought to kind of the Army and then the DoD at large, just the sheer nature of it allows for that combating of a parallel set of threats. And when you combine that with some of the big data techniques that you see in automatic driving and other types of industries like that, you have a sensor system that can see hundreds or thousands of things at the same time, AI that can drive basically an effector that can very quickly determine, okay, here are these drones, 100 drones coming from this direction, hit them with a wall of these frequencies and these waves. Here's another set of drones coming from this direction. Next, shoot the beam over there in a microsecond and put another wall on top of those.
Is that system ready? Have you tested that system that's looking at what's going on in a battle and helping make those decisions?
The system now is in its infancy, but those hooks and those basically that fully automated mode is dialed into the way we architected it. So today the military is not willing to go fully automatic, and there's a whole bunch of discussion we can have around ethical AI and if we're really ready for the robots, so to speak, to start taking over our machines. And in the case of this type of warfare, it's going to be necessary. The necessary decision to go forward with AI controlled battle. Otherwise, a man or a human in the loop won't work.
Yeah, if I have thousands of things coming at me controlled by AI that are dynamic, that are fast, that are hitting me from multiple directions, I sure as hell hope that our shield we're putting up to fight them is also enabled by AI making the decision to put them all down once you tell them that. I think the framework is, of course, you have to agree that it's on a mode where it's going to be shooting things down, but then I think you obviously have to let it go and do it. Otherwise you're going to be a lot slower if a person has to be pressing the button every time. You have all these abilities to know what's going on in the future. You built you have all the money you ever could need. You built some amazing hardware and software, and you know how to innovate. You decided to focus on defense, and you said you want to save the government and the taxpayers hundreds of billions of dollars. Why else is the end role important? Like, what does it mean to you?
Because for the first time in history, most innovative technology companies in America are largely not working with the United States military. That's truly unprecedented. There's never been a point in US history where that was the case. The most innovative technology has always been accessible to our military, and the most valuable companies have always worked with our military. And I think that really gets to the core of why we're doing what we're doing. Russia and China don't have these issues. Their best technology companies are working on defense challenges. Their best people are working on defense challenges. And so if we end up crippling ourselves by putting our best people to work on search engine optimization and ad delivery, how can we possibly expect to compete? And that's what we're trying to build here, is a defense products company, not a defense contractor, but a defense products company.
Is that a sign of a decaying society, that the best people won't even defend their own society, or like, what is it a sign of?
Oh man, I like to think that it's actually just it's like a specific trend of the modern time and strategic foes that are going after. Like, this didn't happen by accident. I think China's done a very good job of making. China does a great job of keeping the entire world, corporate world, on a hair trigger, where they know that if they do anything that is going to upset China, they won't get access to Chinese markets and they won't get access to Chinese. We see this especially in the media with the film studios. You know, the idea of making an anti-China film in the modern day is unthinkable to most of these studios. And so I think that it's not just a sign of moral decay. In fact, I'd say probably 8 out of 10 people working in the tech industry, if you ask them, do you want the United States to have the strongest military in the world? 8 out of 10 would give you a strong yes. The last, you have one of them that says they're not sure, and one of them that would be against it. So most people in the tech industry, I think, do agree. The problem is the corporate dynamics make it more profitable to keep China happy and to not piss off the media, which is kind of disproportionately anti-defense.
Fascinating. So in a sense, you're like 2020's version of a hippie who's overcoming the corporate interest to push what the common people want. I like it.
I didn't know it that way, but it is actually really similar. And like in the same way that I think you had like people complained that we had a disproportionately pro corporate and pro military media. And I think that really has flipped. I don't think anyone would argue that, let's say, the American tech press or even just the press in general is too pro-military. I think that idea, went away long.
100%. So I want to learn more about Anduril. So Anduril, Palmer, like, to me, you've hired like all this amazing talent. You have all these amazing projects you're doing. You're growing revenue faster than any defense company has in history, as far as I know. A lot of people don't have this perspective. A lot of people, they hear these big defense companies who are very threatened by you, downplaying you, talking about how, there's 1 or 2 products, it's not a real defense company. So there's a lot of people who are kind of who want to tell a more negative story. I think it's because they're jealous and threatened. But give us a sense of your success so far. Give us a sense of what you're doing so people can hear it directly from you.
Well, yeah, I think there are people who downplay us, and then they also overplay their competition. They say, "Oh, Anduril's doing great AI stuff, but we have great AI too. It's really, really good," and it's not. It's really cheap to say words. You can just say we're as good as Anduril, and until you actually get to a real field trial, the words are as good as the actual.
That was the same experience with Palantir with me, is that we were competing against a lot of innovation theater where they couldn't actually do it when they actually had to deploy it. It took years to deploy. It took billions of dollars and didn't actually work.
Oh, I mean, for people who don't know what innovation theater is, there's all these people at DoD who have this job. Basically, their job is to generate things that look real enough to make a press release, or to do a panel, or to release a video, or to talk to Congress. And none of it is actually real or useful or deployable. It's pretty wild.